Do I have any questions on anything that was on test review? What's that? Test review.
Hold on a minute, I gotta dig it out. What does that mean?
Huh?
What does that mean?
What's that mean? What?
On that test review?
Yeah, test review 2.
I didn't see anything on numbers on here, so I guess the numbers questions that we do on the test.
What do you mean?
Numbers.
Number systems?
Awesome, all that.
Yeah.
There's nothing in the test system right here that would be cool, but we have something to be cool.
Right. I thought there was something on there. All right, guys, y'all go ahead and open your lab books. This is lab 6-4, which is on page 31. On my lab book, I hope it's the same on y'all's lab book. I think the lab numbers are the same. I'm not sure about the page number. This is an older lab book. You there? I got it on 31. Is that right on y'all's lab book? 27. Like I said, my lab book is older, but the labs are basically, they're still the same. And I noticed this. Well, they give us the motor control circuit. There's something major wrong with this diagram that the author put in there. Some of y'all probably already know what it is, but I'll tell you right off the bat, light bulbs don't have contacts.
The light bulb don't have what?
Light bulbs don't have contacts. Light bulbs do not control contacts. So what the author did, what's that a symbol for? Light bulb. And down here they put a contact belonging to a light bulb. Light bulbs do not have contacts.
But it should have had a motor contact.
Should have a relay contact.
For the motor.
I'm listening.
I don't know. Maybe it was like that red light turn on when that motor turn on.
Yes, but light bulbs don't control contacts. Light bulbs don't control contacts. So here they're giving us a symbol for a light bulb, and down here they're putting a contact that is controlled by a light bulb. Light bulbs do not control contacts. Relays control contacts, but light bulbs don't control contacts. Light bulbs don't control contacts. So what do we need to do? Well, we need to change this drawing because this drawing is totally wrong. Light bulbs do not have contacts. Relays have contacts. This is not the symbol of a relay. That is a symbol of a light bulb. And down here, they're saying this light bulb controls that contact. That would be like you turn on, that would be like a light bulb turning on your stove. Right? You understand that? Light bulbs do not control contacts. Relays control contacts. So we could still call this R, and this could still control a red light bulb, But what you need to do is just mark out these lines going out like that. And then it would be the symbol of the relay. Everybody understand? Yes or no? Light bulbs don't control contact.
And you need to mark out the verbiage of that.
No, it's fine. I mean, red PLT, a relay can control a light bulb, but a light bulb couldn't control. Now, let's see if I can figure out how to bring up the drawings again. I probably need to look. Let me just bring up PowerPoint. So, I think there's a stop button there, right? I'm not sure. I'll go back and look at the diagram. Start button, start button, stop button, start button. And then they're using the switch for the start button. And then we're coming over here. Okay. Now, this would have been legal. Yeah, because we could call this, let's just call it CR for right now. We'll call that CR contact. And then what does this guy control down here? There's another light, right? No, it's a motor. It's a motor starter or motor. Which are calling M1. Now this would have been labeled. Huh?
Contact relay?
No, we call this control relays. I'm just using CR as a generic term. You know, they're going to have a name. A control relay is a relay that never leaves the control circuit. So normally what we do is we have two circuits in control. We have what we call a control circuit. And over here we might have a power circuit. And then I'll come over here and like this is a three-phase motor, which is the symbol for a three-phase motor. And this would be true L1, this would be true L2, and this would be true L3. And that's the problem we get into, is that we call this L1 and L2, but this L1 and L2 over here might be 26 volts AC. This over here could be 660 volts AC. And if you get this L1 confused with that L1, you're going to burn some stuff up. So you got to be real careful of that. So normally in controls, they don't call that, they don't usually call it, in true prints, they don't call that L1 and L2. I think in US Steel prints, they call it PL1 and PL2 to let you know that that is not the L1 and L2 and L3 three-phase. Well, this over here would be my power circuit, and this might be controlled by M1. So on this one, when I close that button, CR comes in. This light also comes on, indicating that we're doing something right. And then CR would close this contact, would bring in M1, and would turn on my big motor out there. This is not a very good circuit because we don't seal it in, And if this switch right here is closed, I press the stop button, the motor would stop, and as soon as I left my stop button, the motor would take off again. Well, all we're trying to do is just look at basic little circuits as we move through this, right? Y'all understand that? So this is not a good circuit, and it's drawn wrong. Light bulbs do not have contact. Now, when I come up here and program this, if it's a CR, by the way, we could say, okay, let's change this up on a PLC. Well, a PLC, what we would do is we would come up here and say, okay, I've got this relay right here, and I got this light bulb, and then I've got this guy down here. Well, on the PLC, we might come up here and do it like this. So we would have this guy right here, right? And of course, this is going to be, we want this to be an examine if closed. And then we'd come over here and we'd hook up something else right here. And then we'd come over here, and then I would come over here and I would put an output. Why does it need an output? Because it's going to control the light bulb. So this would be one of my switches, what they call it, I don't know, PB1, I don't care. And then switch 1, okay. And this right here would be my control L2. And then I've got to assign it addresses. Then I could come down here and do what? Then I could assign this to that output. And then I could come over here. Well, we wouldn't even need that. Let's go ahead and do it this way. We could really strip this down and make it a lot smaller. And this would be like output 2. I agree with you, but I'm drawing it up here, and I can call them anything I want to. I'm making a demonstration. All we got to do is understand, if I call this output, then any contact that's controlled by that, I'm going to give it the same name. So I could have came up here and called this Fred, and then down here I could label this contact Fred, and that means that contact is controlled by that relay. So all we're doing is just trying to demonstrate how. Okay. Are we okay? And like I said, I'm not going to keep switching over to the print. Now, of course, when we wire this up, then we're using 2 outputs. One of them's going to turn on a light bulb, and one of them's going to bring in a motor source. And they called it a motor, but like I said, guys, you're almost never going to find a motor being controlled in the control circuit. It will be controlled by an output on the relay, right? Understand that? And of course, then what I would do is I would come up here. So this is my control circuit. This is my relay logic. This is PLC logic. Now, when it comes time to hook up my inputs and my outputs, so I'm going to have to erase this. I'm running out of room. Everybody okay? And how would I wire this diagram up for the 1100? So over here, oops, sorry. So we got our inputs, and we got our what? Outputs. So here we'd be running syncing. This would come down, right? And then over here, how many push buttons how many inputs do I actually have? I have two. One of them is this guy. And it's going to go to a screw. And the other one would be this guy.
Before we get to top, examine the clothes before we get to top.
What do you mean at the top?
On the input.
When you're in, I don't know what not a normally closed, So we have two symbols for push button, two basic symbols for push button. Then we have variations of this. If it's above it like this, even though a lot of times this author does not leave a lot of room, but you see there's a little tiny space. This is a normally open, and then a normally closed is on the bottom. Okay. So if I look at my diagram on 6-4, it has a normally closed push button. But you're right, we wouldn't be. I know what you're talking about. Yeah. So what we need to do normally, I'm not going to say you're never going to run into it, and what you need to do is you need to just figure this out. Normally we use an examine if closed, but that's not true. I'm sorry. It was right. But we would use a normally closed push button out here. And that's what we're doing. So this says examine if closed. Is this closed? Yes, so it would be true. Right? You understand? Thanks for bringing it up. This is an examine if closed. This is a normally closed push button. Okay, that's not an examine if closed. So what we want is we want this thing to be true when this thing is closed, right? You understand? So right now, this guy right here would be, we would have a nice bright green light right there saying that that is true, right? You understand? So like I said, I'm not going to say you're never going to run into them using a normally closed for a normally closed. That's not exactly true. A lot of times for an e-stop button, inside the PLC program, we would use one of these buttons. Because that button, when you understand, when you hit it, it opens and you want it to close the circuit. So I'm not going to say you're never, ever, 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 ever going to run into an examine if open for a normally closed switch. Because what we want to do for an e-stop button, it's normally closed, and we hit it, it opens up, right? You understand? So we would use this contact. But normally, just for a push button, not an e-stop button, we would use this guy right here for a normal. And then how many outputs are we going to use? We're going to have one output that's going to come over here and connect to a light bulb. I'm running out of room. And then we'll have another one that'll connect to a true relay. And then I didn't do my common. So if we're on the 1100, then this would be sourcing, right, and syncing inputs. If you're on the 1000, then you're going to draw the AC signal. And this would be the true M1. That would be the true M1. And this right here would be the true red pilot light. But what you got to understand is that the way the author drew this, light bulbs don't control contact. Right. Light bulbs just light up. But this author assigned a contact to a light bulb.
So change that R to a relay?
Yeah, just change it to a relay. And then when you draw your outputs, right? Everybody okay? So we, so this is the next circuit. It looks okay. for motor controls. This is the motor control circuit, right? And what we're doing now to start off with is we're taking a motor control diagram and converting it over to a PLC diagram. Okay? Now, of course, when this guy drew it, this is the book I got. What's something they didn't do on their PLC diagram? They didn't put the addresses on there, right? And Nancy signed it off. Yeah, but later on he or she did the same thing, and then she broke that down. Of course, we're modifying our diagrams because we're not using this PLC that this author wrote it on, right? So how are we doing this? If you're on the 1100, you're going to put, how's the inputs on the 1100? Seeking input and sourcing input devices, right? And over here, if you're on the 1000, then you'll put the symbol for an AC as your common. And then our 1100s is running sourcing outputs, so syncing devices. So this one's pretty much the same, except we're going to use an examine if closer. Now, how do we get a normally closed switch? Well, on the 1100s, you just take one of these switches over here that you assigned it and just put it in the on position all the time, and that makes it a normally closed switch, right? You understand that? Everybody understand that? So can y'all see I've got this one on all the time? That might be the stop. Now on the 1000s, we got a little problem in that all these are all normally open contacts. They're all normally open. So what you're going to do to get a normally closed contact is you're going to use one of your selector switches and just turn it on off. And that'll simulate a normally closed contact, right? Okay, does that make sense? And of course, here's our light. Yes, no? Yeah, because it's supposed to be a normally closed switch. Well, we don't have any normally closed switches right here. But these guys right here, you can put them in, you can start these in any position you want to put them in. So right now, I've got this guy here on all the time. So this would be considered to be a normally closed contact, right? And of course, you can flip that. So you can't use these as the normally closed because these are all what? So these go 0, 1, 2, 3, 4. This would be input 5, 0, 0/5/4, 5, 6, 7, 8, 9. Oops, that didn't come out right. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, it's 5 on each side, so that would be 10. And here's your lights. Sometimes they call for a green light, sometimes they call for a different light, so it's up to you. If you want to use red and then one of the yellows, that's okay. If you want to use two of them together, that's fine. All you gotta do is just let me know which one corresponds.
So on that one, we can use the little switch. Last time we did a lab, you said go about what about input source put it in. But like you said on buttons on open, we have to change it.
Yeah, that's what you do on your own. If it defines it as one of these, and you need a normally closed, you can't get a normally closed over here. So just on your diagram, just mark it out and put the one that you assigned. Good question. Yeah, just put a note on. Y'all ever hear that? You okay? On the 1100, you don't have that problem because you control all the switches. So on these, notice you're starting to assign the inputs and outputs over here. So before they assigned them for you, then here they what type of logic is this logic? And yeah. And then this would be or, yeah. L1, L2, or L3. Of course, we don't have limit switches, so you'll just assign it to one of your, probably the best thing to do on these would be assign it to one of your rotary switches on the 1000. Any questions on this circuit? Pretty straightforward. This is 6-6. Yeah, like I said, my page numbers and your page numbers don't line up. Yeah, we're still working in everybody's still working in chapter 6, right?
Well, that's what we're talking about. I don't see the I think 6.5, you want to go to chapter 6.6.
6 days.
There it is. I got it.
Yeah, I remember the lab book is set up where you have a relay, then they have the Logic Pro, which they don't give you anymore. So this lab book could actually be half the size. Are we okay on this circuit? Any questions on this one? This gets a little more complicated. So these are true control relays. And control relays, what's a control relay? Well, this is a relay that has no contacts in the power circuit. So these guys don't need outputs. And what do we use for control relays? Anybody remember? B3. So that's a bit files. In this class, we'll use them for internal relays. These are relays that don't have any contacts in the power circuit. And how many times can you repeat these contacts, guys? This is the problem we have with mechanical relays, is that mechanical relays, these contacts, you're going to be limited to the number of contacts a relay has on them. If these contacts like this, you could have as many CR1s that you need. Because these are all what? These are all soft. These are all programmed, right? You understand? Up to 255 contacts, because that's when we run. They use 8 bits to specify a bit number. So that means we could have 256 starting with 0, 256 contacts. Now on the 1000, it's a fixed PLC. What that means is you get what you got, what you pay for. The 1100 is a hybrid PLC. It comes with some fixed inputs and outputs, but we can add additional modules to that. What's nice about the 1100 is that if you run out of B3s, you can make another B file. I'll show you how to do that on that PLC. But you can make a B10 because we're already using up to 8. You can make a B11, so you could have a lot of contacts on a PLC that's not fixed. So this will be a B3 file. This will be a B3 bit. This will be a B3 bit. This will be one of your outputs because this is going to run a relay somewhere, right? This is a bell. You're going to have to use an output for that, and this is a light. You're going to have to run. You're going to have to put an output for that. Everybody okay? Yes or no?
turns the circuitry on that.
That's basically what a control circuit does. A control circuit turns stuff on and turns stuff on. Yeah, I know what you mean. I'm just saying.
And I'm sitting here looking at it.
It looks like when this switch is closed, and this is a normally closed limit switch. When this is true, this bring in CR1. CR1 comes in here. Okay. It's a normally open because you don't have to worry about this. This is a contact controlled by a relay. So you use whatever symbol it says use. This would be an input, right? Because this is coming up from a limit switch. All this is it's going to be a contact controlled by this guy up here. So if I call this B3, B3 colon 0/0, then you'll use that same address here. But what you do is once you assign a symbol, guys, then for this contact, you don't have to write, you don't have to know the address anymore. You just come up and just type in the symbol name, right? Okay. This will be an input. This will be another B. This will be another B. This might be, B3 colon 0/1. And they're calling it CR2. So this is a CR1 contact, so you'll use the same symbol here. This is a CR2 contact, right? So you'll have to give it a different symbol name. And this button right here is not pressed. Then that's going to bring in M. Then the stop button down here plus CR2. So CR2 has energized. That'll ring the bell. And here, anytime the motor is running, red light will be on.
So what does the bell do? When it comes on?
It's simply all it's doing. Whatever's going on here. These guys are not really circuits that we've used. These are just for you to get experience on doing what? Taking a relay logic program and converting it over to a PLC program. Yeah, if this stop button's not pressed, CR2, the bell's going to ring, which indicates that this limit switch right here is made. So if this limit switch right here makes, then the bell's going to ring, and the stop button's going to, by the way, this is a stop button. This has got the same name. So you don't have to double up on your contacts. You just use the same address, right? You understand? So if you call this guy right here input, 0 input colon 0/5, then you just, and then give it the name stop down here. You just give it the symbol name stop. You just type in stop. So that's another problem we have. Push buttons are only going to have a certain number of contacts. I wish I could find one of these things. They're stackable, and you might see. But here you can use one push button inside your PLC program. You could assign it 100 different times. If this was a push button, it would have to have 100 contacts on it, right? You understand? I've never seen that. That would even be hard to push.
Like the E-stop, they use the examine and open, right?
Yeah, these are not E-stops. These are just stops. There's a big difference between an E-stop and a stop, right?
No, I'm just saying.
I'm listening.
I'm just saying in general.
Go ahead.
Like E-stop, they would use like.
They would use the normally closed symbol. They would use the normally closed symbol.
What I'm saying, it would be like an example of
No, yeah, that's what we would use an examine if open contact for an E-stop. Because an E-stop opens when you hit it, right? You understand? Now, E-stops, they can never be soft. E-stop circuits have to be hardwired. So normally what we would do is, so normally the way it would work, I don't have anything. I need to find something. So normally on my E-stop, we would put an E-stop contact right here inside our PLC step circuit. So what happens is, and then my power supply, we could put it on either side, but my power supply might be like this. So when my E-stop opens, it removes the power from the output mechanically, right? You understand? Now, we might make some decisions inside our PLC program, like stop the program from running. So we might have an e-stop contact inside the PLC program. And that would be an examine if open. But we would also have this circuit right here that would disconnect power from all your outputs. Normally. Your e-stop circuit is not a program circuit. So somewhere we might have a circuit that looks like this. And we could have multiple e-stop e-stop buttons, guys. And then we would come over here. And then we would have like a reset. This would be, and then we'll have an e-stop relay. See, I'm drawing it as a light.
This guy's big and light.
Yeah. And then here, you might have a series of strings. I think on number 4 galvanized line, we had, good gracious, like 30 e-stop buttons, and they was just hooked in series. If anybody come up here and hit one of them, it would stop and drop the line. And what was happening is they would come up and if they wanted to take a break, they'd hit an e-stop button. And what did we have to do? We have to go over this line. It was 3 stories high, guys. And we'd have to go up and down that line trying to find which e-stop button. So we put a panel. They bought some e-stop buttons that had lights on them, and we had an e-stop light panel. So if somebody hit it, you can see exactly which one. So a lot of e-stops have a light circuit on it. So normally this is where we would put our e-stops. Not on our input. We would normally put our e-stop, our electrical e-stop there, and you can see what it does. What does it do? It removes the power from all your outputs. Now, if I needed to figure out what to do in a PLC circuit, then of course, that's about the only place we would use that examine if open. Where am I at? So these are just standard stop buttons. But yeah, that was a good question about the e-stop. Because you're going to run into e-stops. I don't know of any place, any manufacturers that's got anything in motion that you don't have an e-stop on it. Robots are required to have 2. One of them on a T-pendant and the other one on a, but could have more than, yeah, could have more than that. This is 6-7. So anytime you see a CR, you're going to use one of your bit files, right? Well, on the only bit file we have available now is B3:0. And then of course you'll come over here and then you will select a bit, right? So anytime you see CR in here and anytime you see M, these are going to require output, or anytime you see a light bulb, indicator light or illuminator coming. This is where we first see our first memory circuit, or what we call a seal-in circuit. So y'all understand that? So notice we have an M1 and M2, and so you don't have 2 different contacts. And when I come over here and press, now I know this is a normally open because it's drawn above, right? You understand that? And now this author gets them really, really close. But if you look real close, there is a gap right there. So, we come up here, this is going to be an examine if closed. In the relay logic, it's going to be a normally closed push-up button. In our PLC logic, it's going to be an examine if closed, right? Okay. And what are you going to have to use for this? Well, you're going to have to use one of your, on the 1100s, you've got that switch you can close all the time. But on the 1000s, you're going to have to use one of your selector buttons to simulate a normally closed contact. So on this one, we we press PD1, which is a normally open, which is what it's supposed to be. CR1 hopefully will be energized. This guy right here, CR contact 1. Normally, I don't know what this guy's doing. Normally, they don't put the contact number on motor control. They just put CR. Here they're saying contact 1, contact 2. So to get this thing work, what you're going to have to do with this limit switch right here. So right now, if I press the start button, if this limit switch is open, then CR is going to be de-energized. That means these contacts right here are going to be closed. And that's going to bring in M1, which is going to do what? It's going to seal itself in, right? I see that. If I press PB2 and this limit switch is not closed, CR will not be energized. It'll come over here and bring in M2, and M2 will seal itself in. If I press the stop button, then no matter if M1 or M2 is in, both of them will drop out. Or if I do what? Or if the limit switch 1 engages, then it'll kill both of them too. We're okay on this one? And so do you figure out how to do this with PLC box?
If you go to the stop switch, you turn it down. You go to LS1. If that's open, are you saying that kills power on this one?
No, if it's closed. Don't kill the power on everything. It drops the main contact. When you say kills power on everything, huh?
They quit running.
Yeah, the motors will. Yeah, if it hits this limit switch, both motors will cut off.
That's right.
Which here, of course, we don't have motors. What are we going to use?
Whatever that is.
We're just going.
It's hard to get
If the limit switch closes, then that's going to bring in CR. That's going to open this contact and open that contact right there. And which would cause both the motors to, if one motor's running, if the limit switch is closed, you won't be able to start the motor. Right? And then of course, if it's up against that limit switch, you won't be able to start the motor. But if it does hit it, then it don't make any difference if you're running motor 1 or motor 2. They'll drop out until that limit switch comes back on, right? So what are you going to have to use here, guys? Well, on the 1100s, you got switches, but over here, you're going to have to use one of your selector switches, right, for that to simulate that limit switch. Questions anymore? And I think, is that the last one for chapter 6? No, this is a logic probe. So 6-9, we're going to use our latching and our unlatched relay coils. Everybody okay on those? So you can use push buttons on both these. It's no big deal. In fact, that's what I would do instead of using the switch. So the symbol for latch is this guy, and then the symbol for unlatch, I think, is this guy. You need to call me on that if it's not, because the settings uses set and reset. So once we come up here and hit that, when we energize switch 1 or push button there, this guy here is going to latch. It's going to come up here. You can let go of the push button, and that relay will stay true. Right? You understand that? That will stay in until you do what with it. Okay. Unlatch it. I think somebody's tripped this one over here, but we have a true latch unlatch latch unlatch relay over here. Of course, I won't be able to find it. So a latch unlatch, we used to have them on the electromagnets that were on some of our cranes. because these cranes were radio controlled, and if they lost their reset, they lost communication with the box, automatically they would drop everything out in the crane. They would call it losing the reset. But what would happen if that happened and the magnet was holding a load, what would happen? It just drop it, yeah. So we use these latch unlatch relays. You see it says caution latch and relay. It lets you know that right off the bat. This one's been tripped, but it's got two coils on it. Here's the connection for one of the coils that might latch it. And then here's the unlatched coils back here. So we had two coils. We hit one, the relay would latch, and then it would stay in how long? Till we unlatched it. So this is a real latching, unlatched relay. So you can assign this to an output, or you can assign it to a B3, one of your B3 bits too. I don't know what this calls for here. All this does is this guy right here, the unlatch can be assigned to a B3, but the latch has to be assigned. Both these could be B3 files. And then we'll use this one. This right here would have to be assigned to output, right? You understand that? So normally, guys, you don't use your outputs on any relay symbol that does not have to generate an output. We've only got so many outputs we can live with. So if that guy does not turn on a light or it doesn't start a motor starter, then we'll use internal relays, right? You understand that? But you could. Thank you. On my camera, see if I can make this thing focus in. It was doing a pretty good job for a while. And we got another one on latch, unlatch. So how many latching, unlatching can you have? Well, you can. It's PLCs, right? You understand? So the only thing that we're limited to is we're limited to that 255 limit right now, which is not going to come even close to what we're going to use in this class. But most of your modular PLCs and gives you the ability to use data files above 9 for what you need. The 5000 is very similar to a Siemens. So right now, one of the problems they had with RS Logic 500 was that you were defined on your data files. So RS Logic 500 was controlling your memory for you. All your new PLCs, you're in total control of your memory. So you can use a lot more. You can move more toward internal relays, or you can move this way or that way, and there's no predefined memory inside the PLCs now. And right now, my version of RS Logic 5000 is not working. So this is just demonstrating latch and unlatch. So this is the RS Logic programs that's actually running the Festo line, and we'll get over there before the end of the term. And this is B3s. There's a latch, unlatch, latch, unlatch, latch, unlatch, latch, unlatch. So you can see these guys are used a lot in regular logic.
talking about the one that's on 11.
Yeah. We'll go there and let y'all play around with that line a little bit. Probably when we get into the lecture on input output. So this is our lab that we're going to play around with these latch unlatch, and this is just a sequence, and they sequence through this to decide when they're going to actually turn inputs and outputs on. So this is very popular. It's kind of like a sealing circuit, but what's nice about this is your latch and your unlatch doesn't have to be together, right? You understand? It can be just about anywhere. So this is just sequencing through this thing, deciding if these sensors right here are true. That input right there is, and then eventually down here at the bottom of this, we'll get into actually outputs. So you can latch outputs, so that's an output, but instead of using a regular output, they're using a latch, they're latching that output, right? You understand that? So it's a real popular in PLC programming. So that's lab 6. We still got some more in there, but we're going to go ahead and go to lab so y'all can get some lab done before we start the test. So any questions? By the way, for y'all that didn't get here earlier, we did go over the review for the test. And I did give y'all a chance to ask questions about that.
What was that, Rick?
I said for y'all that came in late, we did go over the review for the test.